So my goal is to basically answer two questions: why this is important to do, why we should care about users' freedom, and how we can do that. Okay. So I also have a tutorial after this talk, and the intention of the tutorial is to show some of these concepts that I'm talking about live. So we're setting up a lot of hardware here, and the idea is to show the principles of what I'm talking about and how this can be done as developers. So my intent is very simple today. I hope to make you a little bit uncomfortable about the state of things in IoT and smart electronics. And I also want to fill you with hope on how we can fix some of the problems that I'm going to talk about. Now, the reason I call these, maybe it will be apparent after I have finished my presentation as to why I call these problems and why these are not always thought to be as problems. So let me give you some background. We have a lot more software in a lot more products today. We also have a lot more, we are also producing a lot more free and open source software today, right? I'll come and I'll explain what these terms mean in a little while, but these are two facts. We have software almost everywhere. At the same time, most hardware products that we have, they don't provide us the sort of freedom that they used to provide long time back when they were not that smart, right? So given this problem statement, how do we build such products? That is what we are trying to look at. So let's look at a simple scenario. What are the chances that if you purchase a smart something from somewhere, that it would not require internet access, it would not call home. So what does call home mean? When a device, when connected to the network, starts talking to its developers, to the companies which have built it or supplied it, that's called calling home. Now, there could be some good reasons for doing that, but that's one of the issues that I'm trying to outline here. What are the chances that a smart something would not call home or would not require internet access? What are the chances that it will offer you the freedom to learn, hack, fix, and extend? Which means that, could you take that device or a piece of hardware, smart hardware, and learn about how it is built? Can you study that, the source code or the hardware implementation or the ecosystem of that device, and understand how it's built? What I mean by hack is, well, hacking is a creative activity. It's a constructive activity. When I say I want to hack this hardware, I want to study what it does. I want to maybe repurpose it. I want to look at other scenarios in which I could want to use it tomorrow, right? So would that smart something give me that freedom to hack or fix it? So if I really own something, then I also believe it's my right to be able to fix it when it does not work. Now, the definition of what works and what does not work is a gray area. What I might call a bug could be a feature, but that does not serve my purpose. That is a very simple definition of what we call something doesn't work. And hence, I should always have the ability to fix it, right? So would a smart something give me the ability to fix it or extend it, right? Or would it connect to a third party and still, would it not connect to a third party and still function and operate? Who is the third party? Well, if I'm the owner of the smart something, then everyone else is a third party actually, right? So if I did not allow that device to connect to any third party, would it still operate? Would it still function, right? So these are the three main questions. Let's just think about it. How many devices have you built or purchased, and which of these scenarios do they not address, right? Now let's also look at why we are buying these smart devices. We are looking at connecting everything to the network. We are trying to buy some convenience or some functionality into our lives. We're trying to program our physical worlds, right? There are so many things that we can't do unless we connect all those things to a network, unless we can talk to them electronically, right? So there is a certain advantage in building devices which have software which can do these things, right? There is a certain advantage. No one can deny that. Hardware has had software inside it forever. Right? Today, it is so much easier to create devices because you can define the functionality of the device using software, right? And the hardware itself could be fairly general purpose. So there is nothing to deny that we need these smart somethings, but there is a problem there. The problem is, when we are aiming for coolness, we're aiming for functionality, innovation, what is the trade-off that we are paying with? Right? So we are do we have the sort of privacy we deserve, or security, or can that device track what we do with it? Does it give us the freedom to hack and learn, or the right to fix? So what I'm trying to say here is that these are the costs of having that convenience or innovation or coolness in our lives, right? Now, has this always been the case? No, it's not always been the case. This trade-off has not always been there, right? We have all used computers all our lives. We have used software all our lives. We have not paid for the software by sacrificing privacy or security or our right to fix that software or hardware or whatever else, right? So these are costs that we're trading off right now. On the other hand, there are things that we definitely get when we use free and open source software. And we all know that much of the internet backbone, much of the servers that we use, the operating system backends that we have, they are powered by free and open source software. Today, there is very little that you can do without using Linux of free software, right? So you get privacy because unless there is a reason for that software to connect to the network or connect to a server, it will not do that on its own. And if it did, you could change that because you have source code. You could audit the security. So what do I call secure? A black box cannot be secure because I don't know what's going on inside the black box, right? By definition. By definition, again, something is secure if I can audit, inspect, and verify that it is doing what it says it's doing, right? So without me being able to audit and verify, I cannot know for sure that it is secure. So then I have to take someone's word for it. And then the question is, how do I trust that person's word? So when we're talking about technology and software and programming, we should be able to programmatically verify these things. We should not need to take someone's word for it, right? So the freedom to hack and learn and the right. So, well, what I'm trying to say is that having source code to things is what enables us to have all these rights, all these freedoms, right? And this is something which is default. If you install a piece of software on Debian or Ubuntu or Fedora or Red Hat or any of these operating systems, there's a very, very high chance that it is going to be free and open source software. There is also a very, very high chance that it would ship with source code.